Good evening, everyone. Welcome to Kubernetes Sri Lanka Meetup. Today we have Shivay Lamba, who is a WASM Ambassador. He's going to talk about MLOps with Flyte and Kubeflow. So, Shivay, screen is yours.
Hey, hi everyone, and thank you so much for inviting me over. Super excited to be presenting for this webinar for Kubernetes Sri Lanka. I know Sri Lanka is a wonderful country, and hopefully I get to visit it one day as well. But yeah, without wasting any further time, I'll quickly start to share my screen. So you can probably perfect. All right. So.
Yeah.
Before we kick off, again, a huge thanks to the entire team for inviting me over. And today we're going to be talking about MLOps with Flyte and Kubeflow. So, of course, before we kind of start today's session, it's important to understand that we are in a phase right now, especially in the past 1 year, where we have seen a lot of Gen AI, generative AI being adopted. So, of course, there are front runners and pioneers in this large language space with OpenAI, or even with Google with their Gemini, or before that Palm V2. And you are seeing so many number of like open source large language models like Olama, Mistral, all these like different companies which are releasing these large language models. But apart from just application of directly using these large language models, a lot of companies are equally also looking at how can they implement all of these different applications of generative AI. And for that, they do require infrastructure which is going to be more complex than the standard regular infrastructure that you'll find in a lot of like the regular DevOps workflows that you tend to find in a typical SRE team, right? So the challenges involved with having to work with models that require a lot of size, that is something that a lot of teams are not ready with. And that's why we'll today talk about how you can leverage certain open source tooling that can help your DevOps and your platform engineering teams and your SRE teams to deal with applications or even resources that you require to run all of these large language models and deploy them in an effective and a cost effective manner. So yeah, I think like this, I just want to kind of share the context for today's session, and why is it also really relevant, especially in today's context, and of course the upcoming few months and years. So I think Jamud already introduced me. I'm a WASM Ambassador. I work as a DevRel engineer at Research, and I've been part of the Kubeflow release team, and I've previously been a GSOC and a LFX mentor for the Mesh project as well. But yeah, without wasting any further time, let's get started. And of course, after the session, if you are interested, you can connect with me at the How Develop. And of course, I'd love to stay connected with the Kubernetes Sri Lanka community as well. If anyone wants any, mentorship in machine learning and MLOps, I'd be more than happy to share ideas and connect with all of the folks. So of course, we are in a era where whether we talk about Gen AI, whether we talk about large language models, everything kind of falls back to either NLP, that's natural language processing, or if you're kind of looking at from a computer vision perspective, so things like Midjourney, all these different DALI from OpenAI, all these different models. I mean, the basic construct is going to be deep learning, right? It's the phase of, or it's the part of machine learning which primarily deals with how machine learning models work similar to how our brain works. So of course, a lot of times people ask, how should we get started with Gen AI? So I would say that if you really want to get really deep technically, it's important to have a good foundational knowledge of deep learning. But of course, we've kind of moved away from basics of like deep learning, working with like CNN or recurring neural networks, to of course moving towards generative adversarial networks. So I think like the first wave of like these LLMs, we kind of saw it with some of these models that were released a few years back, such as like the GPT-2 model or the BART model by Google. So GANs at that time were some of the major models that got released like during the timeline of 2015, 2016. But of course, we have, of course, explored a lot more. And of course, even if we just talk about like getting to fine tune these models, it can be a bit tough, right? But imagine that, of course, just getting a good model that can give you a good prediction is just one part or just one piece of the story if you're dealing with deployment. Because if we just talk about any simple machine learning project as well, there are a number of different steps involved, right? You kind of start with defining your problem statement, you get your data set, you are of course making some changes to your data set in order to ensure that basically that thing involves like cleaning it, removing all the unnecessary data. Then you are kind of going ahead and training that particular model with your data. You're queuing it, like if the model performs well as expected, then you deploy it, you monitor it, and then of course you have to kind of scale it up and down based on the traffic that comes to that particular model. So as you see that just the deep learning itself is just one aspect, right? You have all these other steps involved whenever you're having to productionize your machine learning model, and especially like having to ensure that your model performs at all times. And of course, if you just look at the different aspects, this is kind of another way to kind of look at it, where if you're just looking at data collection, right, it's just one small piece. And in fact, like if you are able to see, one of the smallest blocks that we have is the actual machine learning code, which again, as we see that all these different companies are trying to perfect that ML code, that Ola, that Llama 2 model, or that GPT 3.5, GPT 4 model, right? But that is simply just a very small part, and perhaps in this entire vast era. So we see that MLOps is complex because, of course, it involves deployment of your machine learning models and ensuring that you can deploy them in a cost-effective manner. Because costs with running these large models, especially like these LLMs, can turn very costly if you're not doing it in the right manner, if you're not fine-tuning your models. So it's very important to have a robust platform when you're serving, when you're basically serving these models. So the infrastructure in place, or even the monitoring of the models and seeing how they perform, because generally models have this tendency to kind of decay. So you kind of see a plateau, and then sometimes you see a reduction in the effectiveness of the model as you kind of give it exposure to more and more production data. So these are some of the complexities that we have to deal with machine learning. So that is why, as the point that I mentioned, that the infrastructure required for machine learning particularly does not really scale well across your entire SRE or your entire DevOps architecture. Because mostly what, even though we might agree that a machine learning lifecycle is somewhat similar to your standard software development lifecycle as well, because of course you develop the software, you test it, you productionize it, and then you monitor it. So those steps are similar. But what really changes in the aspect of machine learning is that a lot of times machine learning requirements are a lot more compute intensive. So you're having to deal with GPUs more than, like, let's say, CPUs. So that again, GPUs in itself provides an entire infrastructure requirements, unique infrastructure requirements of its own, right? And of course, like when you have a lot of like complex machine learning workflows where you might be running multiple models at the same time, so of course you need to provision your CPU, your GPU. And again, it's not just that you simply just end up running these large GPUs at all times. You have to do it in a more efficient manner. You have to allocate your resources in a more cost effective manner. Otherwise your costs for running these models will just skyrocket, right? You need auto scaling, so that if there is a time, for instance, let's say that there might be certain parts of your machine learning lifecycle which do not perhaps require you to have GPU allocation. If you're doing like something like model cleaning, that part might just be done simply with the CPU. But if you're doing model training, that's where you need GPU. So, or being able to auto scale the different components, having multi-tenancy, and we'll understand like the importance of multi-tenancy as well. Because of course, one of the biggest points over here that I'd like to kind of share with everyone is that typically what ends up happening is that in a team where you have a SRE or a DevOps team and you have a data science team, the data science team might work on their own set of software. So something like using a Jupyter notebook, or some other like kind of notebook kind of interface where they are basically running a lot of different experiments. They are actually creating the models, they are fine tuning these models. But what ends up happening is that the data science team does not really care about the DevOps team. They simply just output the model, and they expect the DevOps team to really just control the model moving forward. Whereas the DevOps team are not really that well versed with having to deal with the model. And then, like, let's say if there are some complexities with model not performing well, they'll have to relay that feedback back to the data science team. So it kind of becomes complex, and it actually increases the number of costs as well, because you're basically having multiple platforms. And these multiple platforms, like, you have different teams working on these different platforms, so supporting costs of running different platforms together, and then the cross dependency on each other, like all of that really adds up to a lot of complexity in the infra and also in the cost. So of course, like, all these are the requirements. And so the simple fact is that if you were to take an existing architecture, it would not work very well with the complex requirements for running these large models and running them effectively. So at times, the DevOps teams simply do not have enough exposure or enough bandwidth to be able to, just directly invoke or directly inherit these machine learning workflows inside of their existing architecture. So we need to make certain changes or introduce certain concepts, and that's what today we are going to be talking all about. And for that, I'd like to introduce today orchestrators. So essentially, orchestrators are a set of tools that allow you to coordinate your logical flow of any kind of compute, whether it's like related to data or related to machine learning, starting from a raw state to a desired state. So an example over here is that, of course, let's say that if we talk about a standard machine learning lifecycle, you start with the raw state, which is your collection of data and cleaning of your data. And desired state is that, yes, you get a well working model that is now deployed. So orchestrators, you can think of them as a way that you combine together your logical steps, and orchestrators allow you to give independent access or independent control to each of these different steps. So you can just imagine the one of the first slides where we kind of covered what are the different steps involved in a machine learning project. You can just directly now apply that to your orchestrators. And of course, the one of the reasons why they're also are really helpful is that you can really set like what are the units of computation that you need for your workflow. You can define that, because of course with machine learning, and especially for like deploying large language models, you need declarative infrastructure. So declarative provisioning of your infrastructure. So what does that mean? You can define, like, let's say you can, when you're like, let's say, running your machine learning workflows on Kubernetes, so you can define your deployments and share that, okay, this particular pod will require access to a GPU resource, or this particular pod might just require access to a CPU. So you need to define that particular units of computation depending on what kind of workload you're running. Then of course, what kind of data or how that data basically work or flows through these particular units, and what is the type of data and the state of the data. Because, like, there can be different types depending on the type of model or what your workflow basically demands. And what kind of dependencies are also required. So if there are any software dependencies or some hardware dependencies that are required to basically run that particular workload. And of course, like, as you're kind of having multiple steps, like we saw in the previous slide, if you have like multiple steps involved in your machine learning process, so you're essentially catering to each and every step of the process and giving them individual access to, let's say, a pod, or to a to a node inside of a Kubernetes cluster, let's say, so that you can give independent access control to each of these particular steps, and each of them can run independently without affecting the other steps as well. So that is why today we'll basically look at two such kind of open source orchestrators. One is Kubeflow and the other one is Flyte. We not really compare between. I'll just give you a brief overview of what each one of them does, and then of course you can choose like which one suits your need better. because both of them do come under the Linux Foundation. So first we'll introduce Kubeflow. So Kubeflow is an open source machine learning orchestrator platform that was introduced by Google, and now it is being adopted to the CNCF, which is the Cloud Native Computing Foundation. And it provides you different set of toolings that not only help you to kind of visualize your entire machine learning lifecycle, but of course it also does help with model training, serving, and automated machine learning as well. So you get a number of different components inside of Kubeflow that allow you to kind of do all of this, and we'll be exploring some of it. Then, of course, in order to basically make your deployments of machine learning on Kubernetes simple, you can do that very easily with Kubeflow. It allows you to define your pods. So since it's natively running on top of Kubernetes. And of course, like one of the questions that people might ask is why run machine learning workloads in the first place on Kubernetes, right? So one of the reasons is that, again, like, because of the fact that you can easily uh, deploy new pods and you can containerize. We are thinking of just running each and every different step of our machine learning life cycle as, let's say, a containerized application. And that's like the scalability of Kubernetes is what we are really looking at, right? And of course, the default RBAC control that you get when you're running these individual pods. And of course, like, it's not tied to any particular tool as well, so you're not like limited to a particular closed source company. So it's a complete open source platform. And again, we'll of course understand more from an architectural perspective that how all these different components inside of Kubeflow kind of work together to kind of help with any kind of workflow, whether you're dealing with just having to deploy your models or you're just using Kubeflow for training. It basically serves multiple purposes, right? So it's a all-in-one tool. You will basically decide on what particular aspect of the tool you want to use it for. And of course, like, these are kind of the major components that you get. So the centralized dashboard, which you see at the top left corner, is basically your UI platform that is a user-friendly interface where you can kind of interact with your entire Kubeflow. So it gives you a good UI platform. Then you have notebooks. So notebooks are basically very similar to how you run Jupyter notebooks, but with Kubeflow, essentially, you can think of these as running individual notebooks or individual experiments on top of pods. So you can not only run multiple experiments for the same projects. Like, let's say you could have the same project running in prod, in deployment, in staging, and in development. And so you can label different kinds of experiments. So it works pretty well out of the box and supporting different kind of experiments. The idea really is that with Kubeflow and even with Flyte, right, your data scientists don't need to go and sit at the corner of their desk, run a Jupyter notebook locally. And just imagine, it can be very hard to then share across that particular code and work together inside of a single team. That is why Kubeflow, you can define pipelines, you can set them up with the help of these notebooks as well, so that you don't have to let your data science team work in a separate location altogether. Like, you can manage all of that together with the inbuilt multi-tenancy as well. So with the inbuilt multi-tenancy, you can essentially take the same amount of resources. So in this case, like, let's say your Kubeflow is running on top of a Kubernetes cluster, so you can define basically, like, you get inbuilt RBAC control or multi-tenancy, so that even if you're sharing resources, it could be like certain number of pods. Your dedicated pods will be used by dedicated teams, and they will only have access to those particular parts of your cluster. So you get native inbuilt multi-tenancy in Kubeflow, that allows, again, experimentation and having multiple teams work at the same time much easier. So they like Catib is primarily used for model uh, deployment and then model serving and all. So, and of course, like, you also get access to directly use Kubeflow with a number of different external machine learning services. So if you're like deploying it to TensorFlow Hub or even TensorFlow Extended, like, all of that is supported out of the box with Kubeflow. And again, this kind of should give you a better idea. So of course, it is running on top of Kubernetes, and you can run your Kubernetes cluster. So there's direct support with GCP, with Azure, with AWS, or of course, like if you want to run it on-prem as well, all of that can be done. But of course, all the Kubeflow applications that you see, including like the pipelines, Kubeflow UI, all of these like that we covered as being the different components, right? So all of those are provided to you right out of the box. And of course, on top of it, we can use any kind of ML tools. So you can very easily support TensorFlow or even PyTorch running natively inside of your Kubeflow cluster. So whatever type of model that you might have that is primarily like, let's say, written in TensorFlow, PyTorch, or even Onyx, those will work out of the box, and you can support pipelines that are running these particular models directly from Kubeflow. So that is a quick overview of what Kubeflow looks like. But of course, deploying Kubeflow does take a lot of effort, which can be, somewhat evident from even like running a simple instance of Kubeflow. You do require like 627 resources, 73 CRDs, 49 different deployments, 6 namespaces. And again, like it's understandable that why is it a bit complex to basically run it. That's because you have so many different components that we saw in the last slide. So again, Kubeflow, as I mentioned, is not just a simple tool. It's an entire platform, right? It's a platform that allows you not only to do the most basic experimentation that a lot of like data scientists will do, but then deploy and serve your models and deploy them on any kind of platform, right? And then of course scale it up and monitor. Like all of that is happening inside of this entire platform, and that's one of the reasons why you have kind of a more complex architecture. So today, like because we have like just a 1 hour session, it's not like a deep dive into Kubeflow. What I'll quickly show you is that, of course, if you were to set up Kubeflow, you can set it up locally also. You can set it up on any of the major cloud providers. So one such example that I wanted to just quickly showcase is with Civo. So Civo is a Kubernetes, it's a Kubernetes distribution platform with K3s. They have this service for basically running Kubeflow as a service. So you can just set up Kubeflow very easily. It takes kind of care of your entire setting up Kubeflow directly, and you directly get access to your Kubeflow dashboard. So I'll just quickly open that up over here. So very easy to kind of set it up. You don't have to do anything. Like all of this is being hosted on the cloud. One of the easiest kind of ways. So before this, Arecto also used to provide like Kubeflow as a service, but since like we don't have a lot of time to kind of set it up on, like, because it might take some time because you have so many different resources, CRDs and everything to deploy. But this is like one of the easiest way to kind of get started. So over here, like this is the overall like platform. So of course, as we discussed, that notebooks are a place where if you kind of like, let's say, create a new notebook, you can see that it provides you a Jupyter lab like experience. I can select how many number of GPUs I want, again depending on what type of workflow that I'm running. So of course, if I were to run something like a large language model, I perhaps might need more number of GPU clusters in my system, and then I can attach data or volumes to it as well, because of course, like since we are running it on Kubernetes, you can attach data volumes as well over here. And the interface that would look like is very similar to your standard Jupyter lab like experience or a Google Colab like experience that you can run. Then we have entire end-to-end pipelines. We'll kind of dive deeper into what pipelines basically mean, right? Some of the just I had already shown kind of inside of the orchestrator over here. Like these are the kind of pipelines that we'll be dealing with. But of course, we'll come back to that particular part a bit later as we kind of cover a Flyte, where we'll do a bit more like deeper example. But of course, you can create experiments. You can run like AutoML as well, or automated machine learning. You can attach volumes to it. You can also run like tensor boards. So you can see that Kubeflow as a platform, right, it provides you a lot of different things. So whether you're just running simple Jupyter Lab notebooks, or you want to have an end-to-end machine learning workflow that you're using at your company, and basically visualize that and control how each and every step of your entire workflow is managed on top of natively on top of Kubernetes. So that's somewhere where you will be using pipelines. Then of course, if you're looking at like deployments, you're basically looking at Catib, which allows you to kind of work with different experiments, and then you can choose where exactly you wish to deploy your project. So that is a high level overview of what is the capability of Kubeflow. But of course, we'll quickly move on to Flyte. But before that, if there are any questions till now, I'll also like to just take up any questions. But of course, somewhere like we can probably see if there are any questions. Okay,
Yeah,
I
so I've been
see.
saying loving the session so far, and also he's asking, yeah, maybe you have heard about Avin. So he's asking, so any word of wisdom for someone who is looking to just get started with MLOps?
Yeah, perhaps I think I'll probably like to take this question at the end once we kind of cover. But yeah, I'll probably be done in the next like 10 minutes, so we can then open up the stage for questions. Perfect. So the other project that I like to also introduce today is Flyte. So this is also another open source project that comes under the Linux Foundation AI. So it's basically not part of the CNCF, but it does come under the Linux Foundation AI program. So it's a separate like foundation within Linux Foundation where you have a bunch of like different AI projects. So primarily Flyte. The way that kind of differs from Kubeflow is that of course like both of them are machine learning orchestrator platforms, but Flyte also does work well with just running any normal data orchestration as well. So it's not just like limited to machine learning. So that's like one of the major differences between Flyte and Kubeflow. And with Flyte, it is more, of course, focused towards the pipelines aspect. So how you can visualize different pipelines. So with Kubeflow, with Flyte, basically, you can define these tasks and these workflows, and we'll see like an example of how you can basically implement it. And the idea really is that if you kind of look at, the high level architecture over here, you have this Flyte cluster running on top of on top of Kubernetes, and basically every single um, and the best way to kind of visualize this is that, let's say if you have a very simple machine learning model architecture where you're first cleaning your data, preparing your data, normalizing your data, then you're training your model, and then you're deploying your model. So each and every particular aspect of your workflow can be treated as a unique task, and this task is basically running inside of a containerized workflow. So you're running inside of a container. So that allows you to then also define at task level that how you want to basically you can essentially run each of these particular tasks in a dedicated pod, so you get resource isolation natively on that particular pod. And then you can scale it up. You can define how many number of GPUs you require. Scaling it up again is very simple. So you will basically take any source code, you'll package it and register it as a containerized workflow, and then you'll run it natively on a pod or on a side of a node on natively on top of Kubernetes. So let's move forward. So as mentioned, like it's a production data orchestrator that for data machine learning as well. And of course, like this is a simple example of like what a task is. So you basically have like an input and an output, but of course all of this is versioned and containerized at the same time. And when you have like a number of different workflows, number of different tasks basically working together, you get a workflow. So one workflow could be just your model training, right? So you start with your data collection, you make some adjustments to your data. So, for example, like use your standard libraries like NumPy, Pandas to do a bit of like data cleaning, remove all the zeros that exist. So you do all of that like basic data cleaning, and then like let's say based on if there's a huge disparity in your data, you are also like doing a bit of data normalization. So all those different like three steps, let's say, could be part of a single workflow. So could be part of a single workflow. So you can basically define these individual units of compute, which like are basically single functions that are interlinked and are logically aligned with each other, right? So they are logically like, because of course like with data cleaning you'll start with collection of data, then you'll move towards like data normalization. So you have basically a logical flow as well that's being maintained whenever you are dealing with workflows. So there's a logical hierarchy of how each and every task acts. Like, so one task will act, the output of one task will then act as an input to the next task. So that's how you basically also maintain them, and you can create different versions of the same. So that, like, let's say if you're running multiple experiments, you can have different versions of your workflows defined, and you can very easily then see that, okay, which one gives you a better result as well. um, and then of course, like as I've mentioned, like you basically if you're dealing with like task and workflows, so essentially under the hood, it's very similar. If you are a Python user and you have previously like used decorators, they are a very simple like similar experience to writing decorators in Python. So you can basically use annotations for task, for defining a task, or for defining a workflow. So here, like we have basically defined an example on the right hand side where you are having like this pay multiplier, and then you calculate the total spend by using both these different tasks. And of course you can use like data frames that come from pandas. You can use PySpark or even like the standard Python data types as well, and you can execute them individually. And of course, like one of the things that kind of is utilized for both Flyte and also for Kubeflow is that they are having inbuilt, or they inherit multi-tenancy out of the box. So you get logical isolation of resources. That means that whenever you're running any kind of workflow natively on top of either Kubeflow or Flyte, you are getting that native isolation because of each of these particular individual tasks running on their own pods. And we also understand that how, just because of the namespace, so the namespace that is also defined is basically defined on the basis of the project plus domain. So in Flyte, for example, whenever any pod is created and whatever namespace is assigned to it, that is a collection of the project and domain. So project are basically logical grouping of these workflows and tasks. And one very simple example is that let's say that you have two different projects. One project is for the data science team, where they are just cleaning the model, doing model training, and then you have a separate project that is for the deployment part of the team, or the MLOps team, or the DevOps team, right? And they just take the model from the project, from the data science team, and they can utilize it. And so you get isolation of individual tasks with the memory, with the the CPU and the GPU utilization, all of that out of the box. You don't have to set it up on your own. So, and you can also like basically also define that within that same project, I can have a separate environment for development, for staging, for production. So you get that kind of granularity for being able to set up your deployments. And of course, as I mentioned, like there is no need for separate cluster altogether for like deployment or for development. You can basically do everything inside of a single platform, right? So inside of a single enablement. And this is like kind of the high level architecture. We'll not like dive too deep into it, but of course with Flyte you can also attach external services as well. So all these like aside from the Kubernetes execution layer, you can attach external services, and again you can run Flyte on top of any general generic Kubernetes distribution provider like AWS, GCP, Azure. You can very easily like deploy Flyte on top of them and then start to execute them. But let's go into some demo time, because I've spent like close to 35 minutes just talking about these two different tools. Now, in order to like look at the demo, right, and I'll quickly also kind of scroll through what we are going to be covering in this particular demo. So first, we'll see that how do we basically get to the resource isolation, because that's one of the most important things, right? If you are building an end-to-end platform which serves multiple teams with different functions, you need that resource isolation so that different teams can basically work at the same time, right? So whether you have a very simple use case where you have just one very simple workflow with team A and then a separate team workflow with the team B, or you have like multiple, like you have more complex architecture. So let's kind of see how that kind of looks like. So for that, what I'll do is I'll come out and I'll now log into my uh, sandbox UI that is provided for Flyte. So of course, similar to Kubeflow, you can also set up Flyte locally in your system as well. I'll recommend to go through that process. Again, it can be a bit time consuming, but I'm going to be showing you a way in which I'm basically running in this again on inside of a Kubernetes cluster. And I'll just quickly also like show you how this would look like. So whenever you're basically starting off with Flyte, you always can start with basically creating and defining like a Flyte workflow. And for that, I'll quickly show you an example over here where let's say that if I kind of showed you this example over here where you have a team A which basically has like, let's say, one workflow defined. So team A could be your data science team, which is running the actual machine learning experiment. So in this case, I have defined like a simple example over here, right? Where I basically import pandas. I have imported sklearn. So these are the simple things. The first task that I've defined is just to fetch my wine dataset. The next task or the next set of tasks that I've defined is basically processing my data so that I can divide my data into a three class, to define it like as 0, 1, 2. And then I have defined a separate task for training the model. And then finally, my workflow is what basically logically groups together all of them. So the workflow logically groups together, starting with getting the data, then processing the data, and then finally training the model itself. So these are the three logical steps that are going to be executed one by one and defined inside of a single workflow. So like, let's say that this is the data science team that is going to be working. So what I'll just simply do is I'll just go ahead and create a new file over here inside of my cluster, and I'll just go ahead and create a new file over here. I'll call it teama.py, and I'll go ahead and just paste this over here. Now, the first thing that I'm going to be doing is I have, of course, like a few of these particular commands that are ready so that I can kind of show you. So the Flyte CTL is like the CLI platform for using Flyte. So the first thing that we're doing is we are basically creating a new project. We're giving it an ID, team A demo, and we are giving it the name as demo data science. So this is going to be a project that will be for the data science team. And of course, with Flyte, as I mentioned, that you get resource allocation dedicated for a particular project. So in this case, like whatever workflows that are part of the data science project will only run in that particular environment. So you get that kind of multi-tenancy, right? So first, I'll just go ahead and register this particular, let me go ahead and do that over here. So you can see that this particular project has been created successfully. I can also go ahead and create another one for the team MLOps so that like we have two separate teams, let's say. So in this kind of a real world scenario, this is something that you would end up basically doing, to have like two separate workspaces, one for your data science team. And again, just remember that this is running on top of a Kubernetes cluster, so you get all of this isolation at your uh, Kubernetes cluster level. And then what I can do is the next step that I have to basically do is I have to register that particular workflow to a particular project. So what does the word register mean? That means that you're assigning that particular workflow to that particular project, so that the project, we are aware on the project level that what kind of workflows are basically running. So let's go ahead and try to run this. So in this case, I'm going to be running the So PyFlight is also basically a so you might have seen like Flyte CTL is the default command line interface that is provided for Flyte, and PyFlight is basically the Python SDK for Flyte. So it does provide you the capability of like registering. So that is the main command. So we are basically just assigning this particular workflow that it's linked with this particular project. Just 1 second. Oh yeah, I'll have to go to that particular folder first. Let's just navigate to the folder quickly. So that will be in the workflows. Then we can run this again. It says module not found. Let me just quickly check what might be the issue. Sometimes there might be an issue with the versioning, and again, like live demos are always the case. Let me just quickly try to update one of these particular packages because it might be happening because of the package. Let me just quickly see if I can get this resolved quickly. Just give me 1 second. It sometimes happens because basically the workflow that we are running inside this cluster, it is running on a sandboxed platform. So it as kind of like a containerized service that kind of spins up this VS Code using a platform called as coder.dev that provide you like this sandbox. So it does come with like predefined versions of these particular individual packages. So I'll just quickly see what might be the latest package so that I can go ahead and install that one. So just give me 1 second, and I'll try to update this fairly quickly. Okay, perfect. So let's see if I'm able to update the package for Flyte kit. Pip install, and then I'll just give Flyte kit. 1 second. Let me see if I'm able to get the latest version because this sometimes gives issue. So I'll just say pip install Flyte kit. So I need to use basically the latest version, and I think I want to basically go ahead and use this. And so I'll just go ahead and install this. So hopefully it installs the latest version. I can also just upgrade the package. So pip upgrade package. Just go ahead and ensure that I'm able to upgrade this particular package as well. So I'll just go ahead and do pip install and add the upgrade. So hopefully this works. Again, live demo is always, an issue. Hopefully this should upgrade the package and it should work. Let's see. But yeah, till then, while this is happening, I'll just see like how much time it might take. Probably it should not take a lot more time. We'll just wait for this to upgrade. Okay, perfect. Now let's try to again run our register command. Perfect. So this time it did register. So it is just a issue with the versioning. And now what we'll go ahead and do is I will go ahead and basically run this particular experimentation. And what you're seeing over here is that we are basically going to now execute this entire pipeline. So we spoke about like pipelines and why pipelines are important, whether you talk about like pipelines running inside of Kubernetes or pipelines running inside of Flyte. In both cases, you're basically running these experiments, right? So I'll go ahead and I'll run this particular command. And what this will do is that it will run this particular pipeline inside of the staging environment, which I've mentioned over here, and it will be running the workflow that's defined in the team a.py. And it's going to be running this training workflow that I've defined over here, right? So let's go ahead and execute this. All right, perfect. And now I can go ahead and visualize this particular execution inside of my Flyte dashboard. So this is the Flyte UI console. Over here, you can see that if I quickly take a look, this is very similar to the graph. So you can see that all of my different tasks are kind of in this kind of a DSL-like structure where you have all of these different Python tasks running one by one. And this is very similar to the orchestrator diagram that I showed you. And on similar lines, you'll have Kubeflow pipelines that work very similar to what you're seeing over here. So as we see that right now, this particular workflow is running and hopefully it gets executed. And while the workflow is running, I can also actually go to the Kubernetes dashboard and visualize the different namespaces that and the pods that basically get created during the time when I'm running this particular uh, entire end-to-end pipeline, right? So if I go over here to, like, let's say the nodes, or even like the pods, perhaps. Let me go to the pods. You can see that we have basically created these different pods which are running these workflows, right? So you can see that the label that has been assigned to, let's say, this particular pod is, or the namespace that has been assigned is team A demo staging. So we initially had this like team A demo, and it's assigned to the environment which is staging environment. So it basically works, that's how you get isolation at a resource level for basically being able to run your namespace alongside the staging environment. So once the entire workflow basically runs, you can see that now all the steps have executed, and you can go at an individual level and see the inputs and the outputs that basically get generated, right? So essentially what happens is that at every step when you register a particular workflow, all the artifacts from that particular workflow get assigned to an S3 bucket, and you then use that S3 bucket artifacts inside of the next step. So that's how it basically containerizes and kind of registers, right? So you might be wondering, where does the containerized workflow exist? So it's basically getting registered. During the registration process, you upload it to an S3 artifact, and you can then use that artifact in the later stages of your entire workflow. And like the DSL kind of a diagram is one of the best ways to kind of visualize it. So that's basically like one example. Now, of course, let's say if you had another team, and for this example, like I'll just kind of define the same. I'll just go ahead and, like, let's say create a new file over here in a new workflow. I'll just go ahead and create a new workflow over here by the name of like team b.py, and I'll just go ahead and save this as well. And I'll just follow the same steps. Imagine that this was a separate workflow where, the team B, which is the MLOps team, was basically utilizing the trained model that we receive from our A team, and they want to visualize it, or they want to utilize it in their own workflow. You could basically do that as well. So for that, I'll just quickly show you, how does that look. So I'll quickly, register it and also execute it. But at a platform level, as you can see, that we basically have like two different type of projects as well, right? So you can see that we have a data science project and we have a MLOps project. And in the MLOps, we are running our completely separate workflow right now. And you can take a look at all the workflows that are running over here, and you can navigate to the data science as well. And in fact, like what you can also do is, this is one such example where, if you want to basically refer to one of the workflows, and again, an example would be that if, let's say, team A, we are basically getting our training workflow done, right? So now you will get a trained model, and you want to now basically collect those model artifacts and utilize them inside of another workflow where you are, like, let's say, doing deployment. So one such example could be, this is another Python code where I'm going to be referring a particular task. So over here, I'm using like a reference task where I want to just use the task for collecting the data. So, you could also have, like, let's say, two separate types of workflows where one team is only responsible for doing the data collection, and then you have a separate team altogether for actually doing the model training. So here's like one example where basically the output that you will get from one particular team, right, or from one particular workflow, you can utilize that inside of another workflow by just referencing it. So here's like another example could be that here you could define your reference task as the outputted, like the predicted model that you have received, and now you are using it for the deployment purpose. So you can also, like, basically take tasks, because of course, like, you cannot just, like, one particular project cannot just directly access the workflows or the tasks from the other team, because you're getting that multi-tenancy and the isolation. So that's how you basically get the resource isolation at that high level. So that's a quick demonstration to kind of showcase that. And of course, you can also get like task sharing. So this is where you refer to one task and you can then call it inside of another task. that's where this particular example which I kind of showed you, and how that reference will come into the picture. And then you can of course apply RBAC control. So basically when we talk about like RBAC, I'm not I think like that particular slide is not there, but you can basically define RBAC control. So when it comes to like defining roles and role bindings, those can also be set up. And apart from that, you can define GPU and CPU requirements on a per pod level. So for example, if you wanted to have, like, let's say some GPU allocation at this particular task level, you could define that inside of training model. So I think assigning GPU resource to task and Flyte, I think like there should be an example um, online, if you want to basically just take a look in Flyte. um, let's see, Flyte task. Yeah. So, for example, like this is probably one example where you can see that as I'm like creating a new task, I can basically also define, like if I want to assign, like let's say a particular CPU or GPU resource, I can actually do that at that particular task level. For example, here, like, is one such example where you can set the amount of memory. And the great thing is that as you're kind of defining this particular task, right? So you can see over here like how much limit you want, how many resources you want at that particular task level. So you can define that on a per task. And in fact, like you can also set like how we kind of create a resource.yaml, and then we basically apply it to our Kubernetes cluster. You can also do that. So if you want to apply it on a pod level, you can do that very easily by defining these. And of course, this also does apply to Kubeflow as well. So you get like our back control as well. And of course, like if we kind of just talk, as we're kind of nearing the end, these are some of the best practices that everyone should follow when you're practicing MLOps. And again, like I'll not go too deep into it, but yes, perhaps like if you're reviewing this, these are some of the best practices that I just wanted to quickly share for MLOps. But yeah, with that, I like to kind of conclude, and I'll be more than happy to take up questions now.
So Shiva, we can go back to the Avin's question, which he asks about any words of wisdom for someone who is looking to just get started with MLOps.
Yeah, so I think even it's a really great question, right? So MLOps is I would say it's a unique mix of both machine learning and DevOps. So at the core level, right, if you just kind of talk about as just a machine learning practitioner or as a data science practitioner, someone who is just getting started, of course, they have all the prerequisites of requiring to learn the basics of machine learning, right? Now, for someone who wants to become, like, let's say, a quote unquote MLOps engineer, you don't need to be that deep into like knowing the mathematics behind machine learning, or you're probably not expected to know the entire creation of a model. Like you even if you're, like, let's say, not having that machine learning researcher level knowledge, you should still be aware of like the basics of machine learning. Like if you're talking about like, hey, I want to deploy my Llama 2 project with Kubeflow, how would that look like? So at least having a basic knowledge of the architecture of these models, I think like that's somewhat is that is important to know that fundamental knowledge. um, and then apart from that, I guess if you can just talk about from a DevOps perspective, of course, you do require DevOps knowledge. Again, you're not really reinventing the wheel. If you have knowledge of like how to use Docker, Kubernetes, computer networking, like all the prerequisites kind of required for DevOps, then you can use that. But yes, definitely like having foundational knowledge of both machine learning and DevOps, I would say, is a prerequisite for MLOps. Now, again, one thing to remember is that as an MLOps engineer, you'll not probably be required to do everything that we just saw, right? Um, and in fact, like a lot of companies might not even use something like Kubeflow or Flyte for that matter. they might just be using their own platform. And in that case, so one of the reasons I wanted to cover Flyte or Kubeflow is that they provided you the entire end-to-end infra, right, or the entire end-to-end platform for being able to manage your not only your experimentation but also your final deployment and your model versioning. But certain companies might not want to do that. They might be using some proprietary software for managing each and every individual component of this aspect. So your role in the company might be adhering to, like, let's say, working with EC2 containers, EC2 VMs, where you're running your model, and you create endpoints that allow you to basically use something like Airflow, or create like pipelines that allow you to basically connect with your and with your workflow and then promote it. So at the end of the day, like, if you want to become successful within MLOps, it's important to have like good foundation knowledge of machine learning, DevOps. And yes, a lot of companies might expect you to have knowledge of things like Kubeflow or Flyte, right, if they are using those platforms. But yes, if you and as a beginner, I would say, like, the one of the best ways you can start is start by creating a machine learning microservice, and then perhaps deploy it on Heroku or on AWS, right? And then learn how you can call that particular, because again, I consider, like, from a deployment perspective, when it comes finally to deployment, the only thing that really changes in comparison to your standard software is, more hardware resource allocation, more GPU versioning, all of that is required for ML. And mostly, like, when you're running these machine learning, models, and you're thinking of them as microservices, right? So ML microservices, the deployment strategy is not that different as compared to a standard software microservice. So I would suggest that if you want to, practice first, like, without using something like Kubeflow or Flyte, you can just start by creating a machine learning microservice, deploy it on a standard VM, or if you want to deploy it as a containerized service, you can also do that, deploy it on top of Kubernetes. That would be the basic building block of like how you can get started, and then you can move further into like how do you monitor it with Prometheus, with Grafana, like, how do you monitor those, and then basically, like, pretty much how you would have an end-to-end productionized setup. Sometimes you might also learn how you basically run different kind of experiments. How do you do unit testing on your machine learning models? So that's also something that you will learn as you'll kind of grow into the overall MLOps ecosystem. So I hope that kind of answers the question.
So I think that's all about question. I think we are coming to end of our session. So since there is no question, we can wrap it up the session for this month. And thank you very much, Shivai, and thank you everyone who attended today Kubernetes Sri Lanka meetup. And see you in next month. Merry
Absolutely.
Christmas.
And thank you so much. And yes, Merry Christmas. Thank you so much for inviting Samad. It is really nice to interact with, the folks from the Sri Lanka community. And hopefully, like, in the next year, I'm able to also come to one of the meetups or KCDs being organized in Sri Lanka.
Yeah, probably KCD. Yeah.
Yeah.
Yeah, nice to have you here. So
Thank you
see
so
you.
much.